We learned about the various components within ComServe, what are their various roles. We learned about few terminologies. We learned about retention. We learned about quota. We learned about how upgrades are done. Theoretically, of course, we'll get into the practicals very soon. Okay. And we learned about how to make certain low level settings and all of that. So now we get into a very important aspect of uh, not just Commvault but any data protection and cyber recovery software, which is the storage. Where are you actually storing this protected data? Okay, like the money inside your vault, right? So we are going to talk about that vault. So how secure it is, how flexible it is, right? Now, time and again, I'll be referring back to certain storage level concepts which we discussed in my fundamentals class, the recordings of which are available in YouTube. So I strongly urge you all that if at all you're unable to follow certain topics, please do ask questions. But at the same time, please do refer back to the data center fundamentals videos on storage, which will give you clarity on certain basic concepts. Okay, because we are not going to touch upon those basic concepts now. We're only going to talk about how it is
Um,
relevant to backup
so sorry to
storage.
interrupt as we're talking, but like if you're sharing your screen, for me it's like a blank white screen. Is it same for the others, or are you guys able to see the screen?
It's a blank screen, sir.
Mm. No, I'm sharing my this one. Let me stop video then.
Yes, sir.
How about now?
Still like a white screen. I can understand something is getting shared, but
Okay. How about now?
uh, for me it's still like a blank white screen.
Okay.
Others like Avya and all, are you guys able to see, or is it same for you guys as well?
Same.
Okay,
Okay. Let me rejoin.
sure, sir. While sir's joining, actually, you guys don't have that phone pay activity.
We didn't receive mail yet.
Oh,
So
okay,
if we get mail, we will be joining there.
okay, sure.
Now is it visible?
Yes, sir.
Okay. And the recording is on, right?
Yes.
Okay. So let's get started with the storage concepts relevant to backup and data protection. So first thing is in Commvault terminology, any storage that you mount or share with the media agent for it to treat it as a backup destination or the end destination where the backup copy needs to be stored. So that is called as a disk library. Okay, it's called as a disk library. If it is a tape, then it will be called as a tape library. And if it is a coming from cloud storage like Amazon S3 or Azure Blob, then it will be called as a cloud library. Okay, but the term is library. Okay, it will be called as a storage library. So in disks again, there are many types of disks that you can attach. So you can attach it over fiber channel, FCP or SAN. You can attach it over iSCSI. You can attach the disk as a DAS, direct attached storage. You can attach it over NFS, like NFS exports, if the media agent is non-Windows. And you can attach it over SMB or CIFS if the media agent is a Windows machine. Okay. And each one of these different ways of mounting or making the storage accessible to a media agent inside Commvault, it will be termed as a mount path. Okay. It is the path from the storage onto which the backup data or the data that is being read from the source, being deduplicated and compressed by the media agent, and then getting stored onto a particular destination, right? So that is called as a mount path. Okay. Now, while the media agent is doing these things, okay, there are other aspects to this writing of data, which also it provides certain controls. Okay. So the first control is watermarks. So you need to know if a disk is empty or a disk is full, right? So those watermarks are something that you can place. Just like in, Zabbix also you do, right? So you put a low watermark and a high watermark and you put triggers to it, right? Very similarly, whenever the media agent sees the capacity hitting a particular watermark, it will throw up alerts. Okay. Then there is a concept called WORM, WORM, WORM. Okay. Uh, and once you use that WORM, WORM, uh, write once, read many, it is called. It makes the data, at least from Commvault perspective, you cannot expire it until the retention period of that data is completed. Okay. So that's called as WORM, and that's where prevent accidental deletion comes into picture. Okay. And
Yes, sir.
then the mount, yeah, tell me.
Nothing, sir.
Okay. And then it also gives the current usage, that how much of the total allocated space is currently being used or being occupied, so that you can do capacity planning also. So if you see that in the next 3 to 6 months, a particular disk is getting full, then you can, you know, make, investments into buying additional storage. So, or you can take certain actions as to cleaning up certain old data which is not required. So all those things, maintenance activities can be done. Okay. Then stream allocation. Okay. So by default, only a few streams, like 4 or 8 streams of backup data, are being written from media agent to any storage. Okay. By default, only four. In some cases, only one. Okay. There are some configurations, only one stream will be written. But we all know that backup windows are limited. That means if you start a backup today, the sooner you complete, the better. Okay. Always that timeline pressure is going to be there. Okay. You cannot have your backups being extended or those backup jobs running forever. Okay. Then you lose that point in time. And when you lose that point in time, your RPO, okay, becomes unacceptable. What is RPO? Recovery point objective. That means whenever there is any data loss situation or disaster, the point in time in which you can go back into the past. That's called the RPO, right? So as and when your backup data backups are taking more and more time to complete, your RPO is, going forward in time. So that's not acceptable, right? So that's the reason why you have to complete the backups as fast as possible. And one control that Commvault gives from the media agent is called a stream allocation. Okay. So dynamically, you can increase the number of streams the media agent uses to simultaneously write data fragments onto the underlying storage. Okay. Now, how will you know how many streams to use? So depending, you should know the storage infrastructure first. Okay. You should know ideally how much amount of throughput it can actually deliver. Then you should see the connectivity from the storage all the way till the media agent. Okay, in between, if there are any switches, then you should take all of that into consideration. See the combined link speed that you have. Okay, and then you will know a fair bit of or you'll get a fair bit of idea that how much throughput you can expect. Okay, if you're not seeing that much amount of throughput, then it's probably because you're not pumping enough data. Okay, so the best analogy that I can give you is, let's say you have a very big fat pipe, water pipe. Okay, and there are hundreds of taps on the other side, and on one side you have a big reservoir, and in between there are some series of pumps. Now, if the people where the taps are complaining that I'm not getting enough force in my water when I'm opening the tap, what could be the reason? The reason probably is you're not pumping it so fast. Maybe enough water is there in the reservoir, but the pumps are pumping it slowly, right? Hence, you're getting maybe trickles of water in the tap, right? Same analogy. If you're not able to write to the storage fast enough, maybe you're not pumping the data, fast enough. That's why it's slow. So one way you can pump more data is by allocating more streams. Okay, so that each stream can now individually push more data to the underlying storage system. Okay, so that is what the stream allocation means. Okay, and then space management. So that is where we introduce concepts like deduplication and then compression. Okay, and these happen on the fly while the data is being written from the media agent onto the storage, and we'll get to the details of it a little while later in our subsequent classes, which will help you understand how to use certain algorithms which are applicable at the data layer to reduce the amount of physical capacity that is required to store X amount of data. Okay. So for example, if the data that I need to store is 100 TB, how can I make sure that this 100 TB worth of data is occupying only, let us say, 10 TB on the disk storage? Okay. So that's where deduplication and compression kind of data level algorithms come into play. And there are different controls for that also. So we will discuss them in more detail in subsequent classes. Okay. So any questions on what we have discussed so far?
I just have one question, sir. For watermark, can we consider that as sort of a thresholds that we set up?
Yes, that's correct.
Okay.
Okay. Just like in your house, if you have a overhead water tank, you'll have
Yeah.
that switch, no, that once it gets full, automatically pump will get turned off.
Mhm.
That's exactly a watermark. So very similar thing you can put for storage also. And as and
Understood.
when the storage gets full or gets empty, you
Mhm.
can get notifications.
Okay.
Okay.
Understood. Yes, sir.
Yeah. Okay. Now we move to the next section. So I'll be providing you this document. Okay. So you can read through it later, but not now. Once you start doing practicals, that is when I will give you this document so that you can relate to what you're doing. Okay. And there'll be some exercises also, which I will give you. Okay.
Sure, sir. Yeah. Thank you.
Yeah. Now, tape is a very unique kind of storage. Okay. Its characteristics, the way you write to tape, the way you read from tape, it's different. It's not like how you read to a hard disk or a flash drive or an SSD, right? See, hard disk or flash drive or SSD, they are random access storage, right? So you can read and write from any part of the physical medium at any given point in time, right? But tape is not like that. Tape is sequential read, sequential write. That why? Because there are spools and the tape tape can at any given point of time move only in one direction on that spool. Either it can move forward or it can move backward. Okay. And on top of that, you will have only one read write head, which will, rub against the magnetic medium on the tape and read and write information on the tape, right? So the way input output operations happen on a tape are very different from the way they happen on a hard disk. But then you will ask me, Array, tapes is something that we used to use in 80s and all. Why are you still talking about tapes? Are you that old? So the answer is tapes are the only medium today available which can be removed and taken off-site from a disaster recovery standpoint or from something called a vaulting standpoint. Okay. You cannot remove a hard disk from the system and still keep the system alive. Can you? You can't. So tapes are the only medium available today which you can attach it to a system, write some data onto it, and ship that tape to some remote vault. Okay. And store it there for disaster recovery purposes. If everything else goes down, your last resort is tape. It's risky, but that's the only option available today. Okay. And that is the reason why till today, every large bank, insurance company, pharma, manufacturing company, any company on planet Earth whose data brings them money, okay, they are going to have at least one copy of their data, critical data, business critical data on tapes and have it vaulted in some secure location. Okay. That place can be a normal bank vault, or it can be a vault that you generally see in Mission Impossible movies, right? So such vaults actually exist. Okay. And critical data is stored there. There is a company whom even we are partners to. It's called as Iron Mountain. Their job is only this. Okay. They create vaults and they run those vaults. Sometimes those vaults are inside abandoned mines. Okay. And they create these strong vaults there. They collect these tapes from customers all across the city, the country, the globe, and they take responsibility of securely storing these tapes in proper temperature, proper humidity, and proper security, and give them those tapes whenever they need. Whenever they ask, okay, I need this particular tape barcoded this, which was backed up on so and so date, it is their responsibility to give the customer the tape within the stipulated SLA. Okay, so that's a proper service that a company like Iron Mountain does. Now, when we come to certain terminology, okay, so the tapes on which you're going to actually write data, it's called as the data tapes, and the media tapes or data tapes. Okay, and the tapes are read by something called as a drive. You can have multiple drives in a tape drive system. So, Saptarshi, in Kolkata, I was fortunate enough to visit BSNL's data center, and I was one of the engineers who was responsible to implement a tape library having capacity of operating more than 1,000 tapes simultaneously. Okay,
Okay.
the tape library. It's so that place is behind ex Jyoti Basu, ex CM Jyoti Basu's residence.
Okay.
Okay, so the tape
That,
library itself is so huge that it's as big as a two-storied building.
Okay.
Okay. And that's connected on, high speed fiber channel connections to the EMC storage which we had implemented, where all the call data records of Kolkata and the adjoining circles would be recorded and stored in real time.
Okay.
Okay, so yeah,
Yeah.
so that these drives are the ones into which the tape will go, and they will start being read or written. Then there will be certain other tapes which are called as a scratch pool, which are used to write some temporary data. Like whenever you're doing compression, wherever you're doing encryption on tapes, the scratch pool is used to temporarily write some information. And later again, once the operation is completed, this scratch pool again goes back to a scratch pool. That means you can keep on overwriting data on top of it. Okay. You can attach multiple tape libraries to a single media agent, and you can have these kind of configurations, right? On the what you see on the left hand side. So you can have a dedicated tape library to a single media agent. You can have a static shared. Static shared means one tape library, you give two drives to one media agent, two drives to another media agent. So that kind of configuration is also possible. That means two read write heads to one media agent, another two read write heads to another media agent, like that. Okay. And then you have dynamic shared also. So you can have a kind of a switch in between. So all the drives of the tape library are connected to the switch. And on the other side, you have all the media agents. Whichever drive is free, the media agent which wants to write to tape will pick up that drive and start writing to it. So that's called dynamic shared. So like this, multiple kinds of tape drive configurations are possible. Okay. And from Commvault itself, these are certain tape level operations that you can perform. Obviously, Commvault cannot automatically remove a tape and put a tape. That has to be done either by a robotic arm or by a person. Okay. Some of the other activities, tape drive operations like resetting the tape, scanning it, and understanding the properties of the tape library or the tape drive. So these are some of the operations that you can do from the Commvault GUI itself. Okay. Yeah, and I was also talking about the nature of data writing and reading pattern onto tapes, right? So as I said, it is sequential in nature. So which means that it is going to be slower to write and slower to read also. Because unless you have read the first byte, you cannot go to the second. Unless you have read the second, you cannot go to the third, so on and so forth. Similarly, when I have to search for data, I have to also search in a sequential fashion, right? To start searching from zero, go until I find my desired data fragment, and then read from that. So because of these reasons, tape reading and reading from tape and writing to tape are always going to be very slow process. And we have to take this into consideration whenever we are architecting the entire system or architecting the entire solution for tape writing and tape reading. Hello, can you hear me?
Yes, sir.
Is the screen visible?
Yes.
Okay. So otherwise you lose the point in time. Okay. So how fast you can write to a certain tape generation, how much amount of throughput you can expect, and how many drives you have at your disposal, what is the connectivity of that drive to the media agent, whether you have enabled hardware compression or not, whether you are doing encryption or not. All these factors will come into play whenever you are trying to architect a solution, trying to size a solution wherein you have to ensure that even if you are writing to tape, the backup copies are completing within the stipulated time frame, or as in backup terminology, it's called backup window. Okay, so the backups have to complete within the stipulated backup window. Okay. The different generations of tapes, they are called as LTO. Okay, for those we don't know. So if you just, search for LTO tape generations, you will find a Wikipedia page like this. Okay. So as you see here, LTO stands for linear tape open format. There's a lot of history behind it. So these are the tape generations as you see here. Starts from LTO1 all the way. It is listed to LTO10, but LTO12 is already on the horizon. Okay. See the increase in density, capacity, performance. LTO1 was released in the year 2000. Okay. Today we are in Jan 2026. Okay. So within 26 years, that means within 2.5 decades, 100 GB tape drive without increasing its physical size, by the way. Okay. The size of the tape drive is still almost the same. Okay. 40 TB you can store in a single tape drive. See the, you know, number of times. So you just use a calculator. 40 terabytes means into 1024 gigabytes divided by 100. So that's 400 times increase in the amount of storage that you can save in the same physical space. Okay, that's phenomenal in 2.5 decades. Okay, then advertised capacity. Advertised capacity means after compression. So normally compression used to be 50%. Okay, that's the best we got for ages. Okay, because of the algorithms. So that's why on a 100 GB tape media, you can actually store 200 GB worth of data. Compression algorithms, though, haven't shown such a stark increase in their efficiency. So on a 40 terabyte tape, you can store about 100 TB. That's about 2.5 times compression, 2.5x. So from 2x, we went to 2.5x. Then you see the speed at which you can write, the throughput. Okay. But this throughput is for uncompressed. And this is a testimony that if you compress, you will lose performance. Okay. So 20 megabytes per second to 400 megabytes per second. So this is a 20 times increase. So this is also phenomenal increase in throughput in 2.5 decades. Okay. And you remember I was talking about something called as warm. See here, it's written, write once, read many, which means once you write to a tape, again, when you put it in the tape drive, it will not allow you to rewrite or overwrite that tape. So that tape becomes warm. Write once, read many tape. Okay. Same concept you can apply in disk storage also. We will talk about it later. Okay. Then you can enable encryption also. Up to AES 256 bit, you can encrypt. And then there is something called as LTFS. We'll not discuss about this right now. It's a little complicated. And partitioning. So earlier generations of tape drives never allowed you to partition. So until LTO4, you could not partition a tape drive. But from LTO5 onwards, you can partition. Of course, LTO5 supported only 2 partitions, but then from LTO6 onwards, 4 partitions per tape drive can be achieved. Okay. Then these are compatibilities. Okay. What does this compatibility matrix mean? It is if you are using a tape drive. Okay. Drive means what? That read write head. Okay. Of a certain generation, it can read and write the tapes of which all generations. So generally, it can do n and n minus 1. So if you see LTO1 all the way till here, right? LTO7. Okay. It can read only current generation and its previous generation. Okay. So in an LTO7 tape drive, if you insert an LTO5 cartridge, okay, or the media, the actual tape, it can't read. So you need to have a compatible tape drive also. Okay. But from LTO7 onwards or LTO7 type M, you see here LTO8, it supports, this one supports 3 generations old. Okay. LTO8, LTO7 type M, and LTO7. Okay. But again from LTO9 and LTO10, only last 2 generations you can read or write from. So this is very, very important, okay, for you to understand compatibility of tape drive with tape cartridges. Okay. Any questions here?
I just have one question. I kind of can we go back to the slides that the PDF that we had, where like two types of drives were getting mentioned.
Hmm.
So for this scratch pool, if I understood that correctly, it stores data on sort of a temporary basis.
Yes.
So what my question would be, so if we do encryption or let's say if you're storing encryption type data, then
Hmm.
if that gets rewritten over that, then won't we have problems later on when we are trying to do decryption or something?
Good question. So that's why when you have a tape library, let's say worth having 100 tape slots, okay, you have to statically define that, okay, which tape slots will be used as scratch. So out of
Okay.
100, let's say you define 5 or 10 to be part of the scratch pool. Okay. So whenever
Mhm.
you insert any tapes in those slots, uh, those will not be used to read and write actual data. It will be only used to do certain backend operations. So the encryption will not be applicable to the tape media which is there in the scratch pool.
Okay. Understood.
It will be applicable only to the tape media which is there inside the actual data drive. So let me do one thing. Let me actually show you so that you can visualize.
Yes.
This is a good. See this. So these are all tapes you can see on the left hand side stacked up.
Mhm.
Okay. And
Yeah.
the ones that are there on the right hand side is uh, green and red ones. Okay. And the one that is there in the middle, that's the robotic arm. Okay.
Yeah.
See, it moves. So it will go scan the barcode. See how big this tape library is.
Yes, sir.
You get it now, what I'm talking about.
Yes, sir.
Okay, let me see if there is any other video. Huh. This is at a smaller scale. So this is a tape drive, tape media that is getting inserted. So just like in olden days, we used to have this VHS, VCRs, right? Very similar, but for data, reading and writing. Okay. So this is, see, generation LTO8. This is called a single tape drive. Okay. Single external tape drive. This is connected over a SAS cable in the backend to your server. Okay.
Okay.
Let me see. These are older tape drive generations.
Okay.
This is a tape library
Booth at HPE
with
Discover 2024, and they're showing
multiple
tape
tape
robot. We
drives.
love these guys. They drive around all day and
See?
move your data and load it and save it and
That's
partition
how.
it. Keep it air gapped from ransomware and all kinds of fun stuff. This is a fun little 3U box.
So this is a two tape drives. So this is one tape drive. This is another tape drive, and inside them tape slots are there. So it
Yes.
goes, puts the tape. It's empty now. It can go and pick up another tape from the slot.
Okay.
Okay, like that.
Okay.
And this is what gets connected to. So tape library. So So basically, you can use direct attach or this is a good one. My ex-employer.
Running
Shell.
breaks your joints. Tai Chi builds them back. After 15.
Hello, my name is Ash. I'm a Dell storage engineer, and I'm
Okay. Yeah, this is called as a SAS HBA. So if you see the ports, these are SAS ports. These are used for connecting tape drives or tape library to a server. So you see this card. This card actually sits inside your server. You see this slot. So this is a PCIe card. Okay. So this sits into a server. And on your tape side, you will have similar ports. Okay. Like this. And all you have to do is connect the SAS cable into that port on the tape drive. Okay.
Okay.
So the SAS cable will look something like this. So this is of course InfiniBand to mini SAS, but many a time SAS cable will have the same kind of connector on the on both sides. Okay.
Okay.
So then you have a 6 Gbps also SAS cable, and you have 12 Gbps SAS cables also. So only thing is the physical connectivity, the cable will look different, as I said earlier. And
Mhm.
because of the media change in media, the speeds will vary. Okay. Now, if you see this, another tape drive. Yeah, here you see these are the SAS cables. So this is a 4 drive tape library. Okay, 4 drives are there in it.
Okay.
This is one drive. So it comes by default with 2 drives. You see here L3 and L4. Now this L4E, this extension, he will remove and he will put 2 new. So this is how the front of a tape library looks like. So you can do some basic operations from here, and you can see drive 2 is not well. Okay.
Uh-huh. Yeah, because they
So
removed that, right? You just have three
yes,
drives right now.
yeah. So all these are field replaceable units. They are called FRUs, replaceable units. Okay.
Okay.
You can take out the power supply. You can take out these. So many components are removable on the field. When I say on the field, it's on the rack. It's mounted on the rack, but you can remove it like this.
Okay.
Like that, you remove the failed component, you unscrew it, you remove the failed drive, and you replace it with a new one. Connect the SAS cable back.
So one drive would be housing a single tape.
At any given point in time. Yes, correct. But in this library, there will
Yeah.
be lot of slots. So this is a 48 slot tape library. So even though you can read and write only 4 simultaneously, physically
Mhm.
you can store 48 tape media inside this.
Okay.
Okay.
Yeah.
But at any given point of time, you can read and write only that many tapes as to how many drives you have.
Okay. So apart from drives, where can we store them then? We have like
So
separate
there are different
storage.
slots for storing the
Okay.
tape. Okay, let me show you. Tape library slots. Okay, you see here, these are the slots.
Okay.
So like this, you can load them into the tape library.
Okay.
Okay.
Okay. Okay. So like if one tape gets filled up, we can automatically not like we can get it from here itself, right? And then replace it in the drives.
Yes, yes, yes. And to uniquely identify a tape, you have these barcodes.
Yeah. Okay. Mhm.
Okay. These
Yes.
barcodes come separately. So you have to manually attach them to the tape. So when the tape comes from the
Okay.
factory, the barcodes will
Uh-huh.
not be there.
Okay. So
Okay.
mhm. Those are provided by the vendor itself.
Yes, yes. But you have to
Okay.
stick them separately. So
All
if
right. Okay.
you see, this is how the inside of the tape library will look like. So once you enter the tape media,
Uh-huh.
the slots will be there inside like this, and this is the robotic arm. It keeps moving up and down. So you see, on this side I have 24, and this side I will have 24. So total 48 tape media I can store on this.
Okay.
Or probably this one is even more, I think.
So that's 48 plus 4, or is it just like total 48?
Total 48. So tape
Total
drives will be empty by default.
Yes.
Okay.
Yes, sir.
This is one more example. Okay. This is IBM's tape library. So the ones on the top are the tape drives, and these are the tape slots. So where you have the physical tape media. So that thing that is moving up and down, this robotic arm. Okay. So
Okay.
that
Yes.
gets the instructions from the controller, and
Uh-huh.
that will then it knows, it has a catalog, it knows where it has stored which tape media with which barcode, and it will go and pick it up from there and put it will get instruction which tape drive to load it into, and it will do that.
Okay. And I
Okay.
guess it can use those wavelength, or I think it was wavelength only, right? To understand whichever one is nearing storage getting filled up. So it can replace
uh,
accordingly.
yes, yes, yes.
Okay.
Okay, the one in BSNL, which I had the privilege of working with, looks something like this. See,
Okay.
I told you, it's
Uh-huh.
as big as a two-story building.
Yeah.
These are all tapes. Okay, see, a human is walking inside a tape library. That's how big it is.
Yeah.
See, approximately 5,000 tapes in here. And this is this robotic arm.
Okay.
Okay, it moves in all directions. And these are the drives in which the robotic arm will come and put those tapes
Okay, so
for read
that's
and write
okay.
operations.
Oh,
Okay, see
okay.
how big this is. And like this, across the globe, there are thousands, not just thousands, I guess, probably more than that, installed in places like BSNL, in banks, okay, in media companies. Okay,
Okay.
now
Yes, sir.
you understand the scale at which we are talking.
Yes, sir.
Okay, and let me tell you, when you see these for the first time, no, it's mind-boggling. It's mind-boggling to see the scale in which data is stored. Okay, and this is the reason why no AI in the world can take away our job. These have to be done manually only. There is no smart robot that can come and replace what we are trying to do.
Yes, sir.
And that's why I keep telling and urging you all to put your time and effort in learning these technologies that you become more and more relevant, more and more sought after in the industry.
Sure, sir.
Okay?
Yes, sir.
Yeah. So any questions? That's why I keep, telling people go on site. When you go and visit data centers, work with customers inside data center, that experience is irreplaceable. Okay?
Yes,
No
sir.
online tutoring, no online teaching can make you better prepared than any data center visit. Just touching them with your bare hands, the concept behind it, understanding the impact and implication of what you're doing and how you're creating value. Okay, it's amazing. Still gives me goosebumps. If I get a chance to visit a data center any given day, I will never say no. As I am the first person to do it. Okay, so
Yes, sir.
I'll stop recording for now, and I wanted to share something which I cannot share
Yes.
publicly.
So just one update in the meantime. These
One
Rakshit and
second, one
Shanil, they
second,
got
one second.